Hello, everyone. My name is Janakiraman from the University of South Carolina, and today I'm thrilled to be joined by one of my co-authors, Justin Kistler from the University of Tennessee, to share with you some interesting findings from our recently published paper in the Production and Operations Management Journal. Before we dive into today's discussion of the paper, Justin and I would both like to acknowledge and thank our co-authors, Subodha Kumar from Temple University and Vikram Tiwari from Vanderbilt University. In this research, we have partnered with the leading academic medical center in an effort to improve the operational efficiency and patient throughput within their surgical services department. So let's talk about this new research. Justin, for the benefit of the audience, do you mind setting the background of the research study? What is the key research question?
Absolutely. Thank you, Ram. So our study takes place within the hospital setting, and more specifically, a high volume surgical services department. So the department that we partnered with was faced with an operational dilemma that is common among many surgical patients. In essence, for all non-emergency surgical procedures, patients typically undergo a series of pre-surgical activities. And we can think of this as sort of a checklist of items that need to take place immediately prior to the patient entering the operating room for surgery. So these activities occur in an area called the holding room, which can typically take around 90 minutes to complete this sequence of activities, at which point the patient then is ready to enter surgery. Unfortunately, at most surgical departments, there's often quite a bit of variance involved in this process. And so we set out in this study to determine how could we redesign the pre-surgical process to improve patient flow.
That's very interesting. What's the main business problem that we wanted to solve that led us to take on this work, Justin?
Sure. So the sequence of pre-surgical activities has to be initiated by someone within the surgical department calling or requesting for the next patient to be sent to the holding room. And so prior to our engagement, this action at our study hospital could be requested by a number of different personnel within the surgical department. In other words, sort of a decentralized process. And while it seems that spreading out the burden of initiating a patient's holding room arrival would actually speed up the process, in actuality, what happened is it was creating somewhat of a holding room traffic jam. So we had patients arriving too early, we had patients arriving too late, and some other requests that were just completely falling through the cracks because one employee thought that another employee had made the previous call. So further complicating this problem is the fact that our partner hospital, not unlike other surgical departments, had nearly 50% fewer holding rooms than they did operating rooms. And they were conducting a very complex variety of surgical procedures at a really high volume. Now, if we know the time required for these pre-surgical activities to take place, approximately 90 minutes, we should be able to standardize when patients need to arrive in the holding room. And doing this can not only increase the operational efficiency and utilization of the holding rooms and operating rooms, but may also reduce excessive preoperative waiting time for patients, which we know is a key source of pre-surgical anxiety.
Right. So how did you and your co-authors approach the research question? Can you talk a little bit about the research design?
Absolutely. So as a matter of fact, Ron, if you could share the slide that you have there, we tackled this problem through the introduction of two distinct yet complementary interventions, which we introduced sort of in a sequential manner. The first thing that we did was address the decentralized manner in which patients were previously being called to the holding room. So to do this, we narrowed the responsibility for calling the next scheduled surgical patient to the holding room by assigning this task to a single employee, the holding room charge nurse. So the charge nurse resides in a central location within the surgical department and has access to a surgical tracking system, which provides real-time information on all ongoing in-progress surgery cases. We can think of this as sort of akin to an air traffic controller with access to information on all arriving and departing flights. So armed with this information, the charge nurse can better assess the appropriate time to call the next scheduled patient to the holding room. Essentially, we've centralized the decision-making process to initiate the arrival of the next patient. So that's the first change. The second operational change that we introduced was to design and enhance the accuracy of the information that the charge nurse was basing their decision-making on. So traditionally, a surgery start and end time are predicted based on some sort of historical data about a similar procedure. So for example, if most knee replacements take an average of 2 hours, well, then we assume the next one will also. In reality, it's very common for surgeries to take longer and sometimes even shorter than anticipated based on the unique health conditions of each patient. something that typically we don't discover until surgery is actively underway. So knowing this, we implemented an intraoperative IT prompt, so basically a pop-up window that appears in a documentation screen within the operating room during surgery. The operating room staff can then use this prompt to confirm or revise the expected end time for each in-progress surgical case, which enables enhanced information for which the charge nurse can then integrate into their decision-making process for calling the next scheduled patient.
Okay, that's very interesting. What is unique about this research, Justin? Can you explain that?
Sure. So very briefly, we've built upon concepts, centralized decision-making and enhanced information sharing, which have historically proven effective in traditional goods supply chain settings. By testing these concepts via a field experiment in the healthcare setting, we're able to empirically demonstrate that such supply chain concepts can also generate operational improvements in the movement of patients within this highly complex hospital environment.
Okay. Justin, you previously described what sounded like two very valuable solutions. Really, how beneficial were they for the focal hospital partner? Can you talk about that?
Of course. So we found that the first process change, where we centralize decision-making, can actually reduce the average patient's time in the holding room by about 3.4% compared to holding room stays that were occurring prior to this intervention. Even more interestingly, when we layered the IT prompt on top of the initial centralized decision-making intervention, we discovered a 10.8% reduction in the average time spent in the holding room. So this tells us that although having the first intervention is beneficial, we can actually increase its benefit nearly 3 times by integrating both solutions together. So although we don't have enough time to delve into it today, we also conducted some additional analysis which showed a differential impact of these interventions based on the relative level of experience that surgical staff have with the baseline process at our partner hospital.
Wow, that's a substantial operational improvement for what seems to be rather minor changes to an existing operation. Tell me, Justin, what is it about your findings that you would like people to walk away from this discussion with?
Yeah, you're absolutely correct. So we were able to achieve these benefits with only slight adjustments to the duties of existing staff members and a reasonable level of staff training or development cost. As a result, my colleagues and I would like the managers of service operations and those managing healthcare processes in particular to know that the process interventions implemented in our work can enhance the coordination of activities and information flow within their organizations, which can ultimately result in increased operational efficiency and cost savings. In addition, we want to emphasize that these concepts of centralized decision-making, enhanced information sharing, are again often thought of as best implemented in the context of a physical goods supply chain. However, our work has demonstrated that these concepts can yield pretty remarkable process improvement in a highly complex service setting such as a hospital.
Real quickly, Justin, in the last few seconds that we have, where do you and your colleagues intend to take this work next?
That's a great question. And basically, we're actively looking for some other service operations and industry partners, both inside and outside of healthcare, to test these theories in the hope that we can broaden the impact of our work into many other operational areas.
Thanks for your time today, Justin, and thanks for joining us.
Thanks for having me.